Right, section 12.4, page 137, solving quadratic equations by factorising them. Now, here's a ready factorised equation, and the only thing hard about these things is that if it's not given to you in the factorised form, and it probably won't be in the exam anyway, then you've got to be able to factorise it first, which is what the previous video was about, and then solve it. But look how easy solving is. M minus 3 multiplied by m plus 2 comes to 0. So let's just do this little bit. Now, m minus 3 alone equals 0, therefore m equals 3, one solution. I've got m plus 2 equals 0, therefore m equals minus 2. Now look, in the context of seeing that, I mean, you know, if you multiply this out and simplify down, you get a quadratic equation with m squared in it, plus some m's, plus minus 6 at the end. So, if you were to plot this as a graph, we'll have one solution there, where that will be the point minus 2, 0. And you'll have another solution about here somewhere, and that will be the solution 3, 0. And the graph will look a little bit like this, okay? Like that. Up to that point there, very hard to draw. So if this was really x instead of y, instead of m, then that will be the equation would in fact be something like x minus 3. That will be exactly this, multiplied by x plus 2 equals 0. Let's see what the original equation would have been anyway. Multiplying out, it's only a grade B one. I've got x squared plus 2x minus 3x minus 6 equals 0. So x squared 2 minus 3 is minus x minus 6 equals 0. So that was the original grade B quadratic, and if you were to plot that graph, that lovely curve there, taking a range of x values, then you would in fact get that curve, and there'll be two solutions, because where x squared minus x minus 6 equals 0, I've got the line y equals 0 here, which is the x-axis, and where does y equal 0? At the point there and at the point there. Hence the two solutions to the equation is going to be minus 2 there and plus 3 there. And in terms of plotting the thing, that's how it would look, and that's where it would cross. So it makes more sense when you see the picture, the graph of how it would look. But you don't have to do this every single time. Just that it's nice to know that when you used to plot these things back at grade C, it produces that shape and provides two solutions because of what we've done here, and it's easy to see why that's true. So I won't do that again. In fact, I'm not going to provide any more ready-made factorised ones because that's too easy. Let's just do this grade B one here. This is question, well, it's grade B. Solving. Right, here's another one. Question 4. Y squared minus 2y minus 15 equals nothing. So factorising that, two brackets all come to nothing. Y times y is y squared. How do you make 15? 5 and 3 makes 15, and will give me a space of 2, won't it? Because 3 and 5's got a gap of 2. I want to make minus 2, so I want minus 5 and plus 3, and 3 times minus 5 is minus 15, so that's correct. Right, each little bit then is worth 0, so honestly, y plus 3 is nothing, so y equals minus 3, y minus 5 equals 0, so y equals, take it over next door and add it, 5. Two solutions. Peasy peasy. Right, anything half decent here? Let's just do this one. I've got p squared plus 5p equals 14. Oh dear, not equal to 0? Well, jolly will make it equal to 0. So p squared plus 5p minus 14, bring it over, equals 0. Again, do the usual thing here. P and p, how do you make 14? 2 sevens, yes, 7 and 2, 2 sevens, that'll give me a 5, won't it? I want to get positive 5, so the 7 must beat the 2. So 7 take away 2 is 5. 7 times minus 2 is minus 14. I know it's right. So straight away, p equals negative 7 and p equals 2. Two solutions, and I'll get a grade B for that. Don't be baffed by this one. T squared equals 100. Now you know there's two solutions to any square root. So basically t is going to be the plus or negative roots of 100. In other words, two solutions. Roots 100 is 10 or minus 10. That's the negative solution to the square root of 100. And what else we got here? This is question 10. I've got a squared plus 7a equals nothing. Again, single factor. Take a out. Leaves me a plus 7 indoors equal to 0. So what have I got? Straight away I've got a equals 0. There it goes. And I've got a plus 7 equals 0, and therefore a must be minus 7, as the second solution. Alright, so two answers, A equals 0 and A equals minus 7. Do a couple of grade A ones. Let's do the first grade A one here. I've got 2b squared, question 11, minus 8b equals nothing. Let's factorise it down. Well, divide by 2 throughout really. So divide by 2, make it simple. So I've got b squared minus 4b equals nothing at all. Factorise to get the b out. So b bracket b minus 4 equals 0. Straight away I've got b is 0, b is 0. And for this little bracket here, I've got b equals 4, because 4 minus 4 makes 0. There's the two solutions to that one. Turning over, let's find a more challenging one. 3y squared plus 8y minus 3 equals 0. There's no common factor there, so I can't divide throughout by 3. Just get on with it and factorise it as normal. So 3y and y, again we've done factorising before, so it's not such a big issue. How do you make 3? Well, 3 times 1. 3 3s are 9. I want it to be positive because I want 8 y's, and take away 1 y would give me 8 y's. Minus 1 times 3 gives minus 3, so I know the factors are right. Now let's just take these one at a time. 3y minus 1 is nothing, so y is going to be a third. What am I doing? Take the 1 over and add it, divide by 3. Dead easy. And here I've got y equals minus 3. There's the two solutions. Please note it doesn't have to be a whole number. Whatever is right is right. That was question, let's do question 15 now. Over here I've got 5t squared minus 3t minus 14 equals nothing. No common factors. Jump straight into factorising. 5t and t. How do you make 14? I don't know, 2 7s I suppose. If I put a 7 there, I end up with 35 t's, so that's too big. Again, you're allowed to think on your feet like I am. You're going to have to do in the exam anyway, you've only seen these before. So what about 7 and 2 then? How about 2 there and a 7? Yeah, I feel happy with that, because 5 times 2 is 10, and 7 times a single one is 7. 10 and 7 will give me 3, so I'm really happy with that. I want minus 3 to win, so let's have a look. 10t squared, if I go for minus 10t plus 7t, that will give me the minus 3t that I want, and 7 times 2 is 14, but it's negative because the minus there. Now just go ahead and solve. So I've got 5t plus 7 equals 0, so t is going to be minus 7 over 5, or better still, just untop heavy it, minus 1 and 2/5. Very, very ugly, but beautiful because it's correct. And here we've simply got t equals 2 for the second solution. I suppose I better do the last one because I suppose it's more challenging. So let's go 16 over here, move this pad along a bit, getting a bit cramped in this space. What's that? 16, right. 2p squared plus 13p makes 7. Bring the 7 over. 2p squared plus 13p minus 7 equals 0. Now we can just factorise in the normal way and get some solutions. 2p and p. How do you make 7? It's going to be 7 times 1. My instinct put the 7 there because 2 7s to make 14, and that's close to 13. And right, I want it to be positive to give me 14 p's, and I want that to be minus 1 to give me minus 1p. 14 take away 1 is going to be 13 p's, and minus 1 times 7 makes minus 7, as it says in the equation. Right, solve them straight in. P equals 1/2, p equals minus 7. That's all there is to say about that.